Hello, and welcome to 5-Minute Math. Today we are looking at the fifth grade concept of area, perimeter, and volume. This is 5.4H, Readiness Practice, the intermediate version. If you are interested in exploring the 5.4H Readiness Practice for the proficient or advanced versions, or the Readiness Practice resource along with any other standard, you can find those by using the link in the video description. So we have a rectangular picture frame. Whenever we see a problem like this, let's immediately draw a picture, just so we can kind of visualize this. So here's a rectangle. Now, what do we know about it? It has a perimeter of 80 degrees, all right? So P equals 80. So the shorter side is 15 centimeters. Now, there's two ways that we can do this. We can just kind of visually use this rectangle to figure out how much, what is the length of the longer side, or we can use our formula. Right, so remember our formula is P equals double the length plus double the width. And so let's call this 15 centimeters our shorter side. And we know our perimeter is 80, so we're going to say 80 equals 2 times 15 plus 2 times W. So really this is 80 equals 30 plus 2 times W. And that's my question is, what is this W? Well, 30 plus what gets me 80, right? This needs to get me, I'll put this right there, that needs to get me 50. So 2 times what gets me 50? That's what I'm thinking. I can also just look at it like this. I can say, well, that's 15 centimeters, right? So this right here is 30 centimeters, and it's going to be that same thing. If the whole thing is 80, and I've already used 30, that means I need 50. But it's not just 50. The answer is going to be 50 between both of them. So I need to take that 50 and I need to cut that in half. So half of 50 is going to be 25. And so what I could do here is I can just write 25 on each. And then if I double check that, it's going to get me 15, 15, 25, 25, 5, 10, 15, 20, 2, 4, 6, 7, 8, 80. So the length is 25 centimeters. And there's a few different ways that I showed you that we can solve that with either a picture or with using just the expression is 25 cm. And let's put a green box around that. All right. For our next problem, we have a rectangular base. Box has a base of 6 inches and width of 4. Box is filled with unit cubes, and we're trying to figure out what is our volume. Really, when we're talking about the box is filled to a height of 3 inches, how many unit cubes? That lets us know we're dealing with volume. All right, so let's draw a rectangular prism here. And let's see, we'll just kind of do it like this. We're just going to kind of draw that same shape in parallel up at the top and kind of connect our points. It's not going to be perfect, but it's at least going to, it's going to give us something to at least look at, right? All right. And honestly, these back here probably should be dotted to show that they're in the back. All right, so we have a length of 6 inches and a width of 4 inches. So I will call this 6 inches, and I will call this 4 inches. And we have a height of 3 inches. All right, so I made it too tall, but that's okay. So we'll say it's 3 inches. There's my height. So there's my length, there's my width, there's my height. Remember, volume equals, there's two different ways to think of it. Length times width times height. We can also see volume, and starting middle school, we're going to see it like this, base times height. Well, obviously the heights work together. Base is literally just the area of the base, which in this case it's a rectangle, which means it's length times width. So when we're thinking base times height, it's the area of the base, and that goes into right there. So this is a pretty simple, straightforward problem. We're going to take volume equals 6 inches times 4 inches times 3 inches. And that's going to let us know how many unit cubes we can put into this particular box. And so that's going to get 6 times 4 is 24, and then 24 times 3 is 72. So 72. Now we can either write it like cubic inches, or we can write 72 inches cubed. That's a little 3 exponent, just like a little 2 is square, a little 3 means cubic inches. And so either one of these ways of writing it is going to be correct. We can put 72 cubes. And so we'll say 72 cubes can fit in the box. Since the question is really asking how many cubes can fit in the box, let's just go ahead and put it in terms of cubes. For our third problem, we have a rectangular box. Has a volume of 240 and a length of 10 and a width of 6. We need to find the height. Okay, so let's draw another box. We'll try to make this one a little bit neater. So dotted lines in the back to recognize that it's going to be kind of in the back. And we could do a parallel, because really what you're drawing here is a like a parallelogram. And you're wanting to kind of draw. Now, since you're doing the top, you're going to see all of those. So you could do solid lines. It's the one in the back you need to do a dotted line. All right, so there's my rectangular prism. We have a length of 10. We have a width of 6. We're looking for the height because we know the volume is 240 cubic inches. All right, so remember, volume equals length times width times height. And my volume is 240, so we can say 240 equals, length is 10, width is 6, times height. So 240 equals 60 times my height, because that's what the 10 times 6 gets me, 60. So how many 60s does it take for me to get up to 240? Well, think how many 6s does it take to get up to 24? Because there's a 0 on each. We can just ignore those. 60, 120, 180, 240. So that means all I need is a height of 4. And so to put in units, we can say the height is, we're dealing with inches, 4 inches. Because that 4 times 60 is going to get me 240. If you are interested in exploring the 5.4H readiness practice for the proficient or advanced version, or the readiness practice resource along with any other standard, you can find those by using the link in the video description.